Hello everyone, my name is Sabrina Jackson and I did my research on characterizing the performance of rapidly degradable polyaldehydes as dry developing photoresists. I conducted my research under the advisement of Dr. Paul Cole and Anthony Engler at the Georgia Institute of Technology. Photolithography is how developers pattern computer chips. The conventional way is by a wet development process that can be very toxic. The first step is to spin coat the wafer with photoresist, soft bake it, and then expose it through a photomask. This causes a solubility switch, which requires a hard baking process and further development by a tetramethyl ammonium hydroxide solution, which can be very toxic. However, my research uses rapidly degradable polyaldehydes as photoresists, which allows the developmental process to be dry and not involve the use of toxic materials. This is because when the photoresist is exposed to the photomask, it causes the polyaldehydes to depolymerize into small molecules, which can be easily developed using a heat or vacuum oven. The project goal was to characterize the performance of dry developing photoresist materials, and this can be done by finding the D100 value, or the sensitivity value, and the contrast value. Polymer degradation is enabled by low spinning temperature polymers. The polymer that we chose to use was ortho-phthalein, which has a low spinning temperature of -40 degrees Celsius. The two polymers that were created was the homopolymer and the copolymer. The way we characterize a photoresist is by doing a contrast curve. The D0 values is when the photoresist starts to develop, and the D100 values is when the photoresist is completely developed. The contrast value can be found by using a formula 1 over log base 10 D100 over D0. We are comparing our photoresist to the commercial value of a target contrast between 2 and 5. The contrast values are created using a contrast mask that lets different doses of light be produced onto the substrate. The contrast values were tested using a profilometer. The components that I varied were the two polymers, the homopolymer and the copolymer, the weight percent PAG, and the exposure dose. I kept the same pre-baking process at 3 minutes at 150 degrees Celsius to get a target film thickness of 280 nanometers. I used two methods of development: thermal, where I varied the temperature and the time, and vacuum development, where I varied the pressure in the vacuum oven and the time in the oven. For the homopolymer, the vacuum development at 5% PAG and thermal development at 1% PAG worked the best because of its high molecular weight, which produced the high contrast values. However, for the copolymer at 5% PAG, vacuum development worked better because of its low molecular weight. For all of the vacuum development experiments, the lower the vacuum pressure, the better pattern fidelity and sharper the features were observed. However, for the copolymer at 1% PAG thermal development, it didn't work because no conditions fully developed the substrate due to the lack of acid molecules and a low molecular weight of the copolymer. Lastly, some things that I would like to continue with in the future would be to test my experiment and the atmosphere around my experiment for developmental processes and attempt the pattern transfer process. Thank you so much for your time, and I hope to hear from you guys soon.